Solving a system of linear equations using the elimination method. So this is the third method that we're going to have in our toolbox for solving linear equations. The first one was graphing, the second one was substitution, and now the third one is elimination. Elimination works best when both equations are in standard form. ax plus by equals c, which basically means x and y are on the same side. The steps: multiply if necessary to get one of the variables to have opposite coefficients. So let's look at example 1. 3x plus y equals 8, negative x minus y equals 0. We already have the variable y with opposite coefficients. Step 2, add the two equations together to eliminate one variable. So I can add these two equations together. 3x plus negative x is 2x. Y plus negative y is 0. The y is eliminated. 8 plus 0 is 8. Step 3, solve the resulting equation. Divide both sides by 2. X equals 4. And now we're going to use the same steps we did for substitution. Step 4 is to substitute the value found in step 3 in either of the original equations. I'm going to select the first equation. So I have 3x plus y equals 8. I'm going to plug in that 4 for x. 12 plus y equals 8. Subtract 12 from both sides, and y is equal to negative 4. So step 5 was to solve for the remaining variable and write your answer as an ordered pair. X is 4 and y is negative 4. Example 2. Multiply if necessary to get one of the variables to have opposite coefficients. Well, we have choices here. We have a 2x and a negative 4x. We can multiply the first equation by 2 so that we'd have 4x in the first equation and negative 4x in the second equation. We could also multiply the first equation by negative 1, so we have a negative y and a positive y. We could also multiply the second equation by a negative 1 to eliminate y. And it doesn't matter which route you choose. I'm going to select to multiply the first equation by negative 1, and this is how I show my work. I'm going to multiply each term by negative 1. Negative 2x minus y equals 4. I'm going to bring this equation underneath so that when I add the two equations, y is eliminated. I am always going to add. So when I add the two equations together, y is eliminated. Solve for x. I'm going to divide both sides by 6, negative 6. So x is equal to negative 2. Now I'm going to take x is equal to negative 2 and plug it into one of the two original equations and solve for y. And I'm going to pick the second equation. Write my answer as an ordered pair, negative 2, 0. Example 3. The objective is to have opposite coefficients. So when we look at the x's, if we multiply the second equation by negative 4, that would give me a positive 8x and a negative 8x. That would work. If I wanted to eliminate y, I could get one of them to be a positive 12 and one to be a negative 12. If you wanted to use 24, your numbers are just going to be larger. But you're looking for the least common multiple of 6 and 4, which would be 12. But I am not going to multiply both equations by a number if I don't have to. So I'm going to elect to multiply the second equation by -4 so that I will eliminate x. Multiply each term by -4. Add the equations. (8x plus -8x is 0. It's eliminated. 6y plus -16y is -10y. 34 plus -64 is -30. Divide both sides by -10. Y is equal to a +3. Substitute 3 in for y into one of the original equations. I'm selecting the second equation simply because the digits are smaller. Solve for x. X is equal to 2, y is equal to 3. Write your answer as an ordered pair. And there you go. Example 4. You'll notice that both x's have opposite coefficients. Both y's have opposite coefficients. So we're going to have to multiply both equations by a number. And it's just a matter of whether you want to eliminate x or you want to eliminate y. I'm going to elect to eliminate y. I can multiply the first equation by a +3. That'll give me a -15y. And the second equation by a +5. That'll give me a +15y. If you wanted to eliminate x, you can multiply the first equation by 2 and the second equation by 5. So multiplying everything by 3, we get 15x minus 15y equals -30. Multiply everything in the second equation by 5, -10x plus 15y equals 25. I'm going to add the equations together and eliminate y. So 5x is equal to a -5. Divide both sides by 5, x is equal to -1. Substitute in -1 for x in one of the original equations. I'm going to select the -2x plus 3y equals 5. Y is equal to 1, so our point of intersection is at -1, 1. All right, and I would like to just show you here, if you would have eliminated x, what that might look like. So we would multiply the first equation by 2 and the second equation by 5. And that would give me 10x minus 10y equals -20, and -10x plus 15y equals 25. And that would give me 5y equals 5. Divide both sides by 5, and y is equal to 1. So the reason I'm showing you this is because you have choices. You can use elimination, as I did in the gray ink, to get x is equal to -1. You can use elimination again and eliminate x and solve for y. You can use double elimination, or you can use elimination and then substitution. Example 5. Again, the objective is to get opposite coefficients. We can multiply the first equation by 2, and that would give me a -2x and a positive 2x. And I'm also noticing the y. I can multiply the first equation by 2 and eliminate y. So let's see what's going on here. So multiply every term by a positive 2. When we add the equations, both variables are eliminated. So we have 0 is equal to 20. The variable has been eliminated. The result is false. So we know this has no solution. The two lines are parallel if we were to graph them. And example 6, I'm going to multiply the second equation by 3. When I add the two equations, the x's are eliminated, the y's are eliminated, so I have 0 is equal to -9 plus 9 is 0. So the variable's been eliminated. The result is true. So we have infinite many solutions. So we know that those two equations are the same line. So when you are using elimination as your method for solving, keep in mind your objective is to have same but opposite coefficients for one of your variables, so that when you add them, the variable is eliminated. You might have to multiply both equations by different numbers. One could be positive, one could be negative, but understand the objective is you're multiplying in order to have opposite coefficients, so when you add the two equations, the variable is eliminated.